Hello students, today we will discuss about the second part of Introduction to Nanoscience and Nanotechnology. In the last class, we have seen that we were asking ourselves whether nanoscience is just seeing and moving these really small things which are in the nanometer dimensions. So we answered it as a positive thing that we are actually going to look things in the smaller dimension, but we'll be also investigating what is the change in properties of materials once it comes to the nano dimensions. So what is nanometer, nano dimension? Yeah, it comes in the range of nanometers, that is 10 raised to minus 9 meters. So this is the same material in its different nano dimensions. Like change in a very small change in size can lead to different optical properties. So let us start with a familiar thing, that is a gold, and we are all very fancy of gold because it is yellow color. It prolongs its color for a longer period. It doesn't get tarnished so fast, and hence it is used as a ornament. Now let us take a cube of nano or a gold piece and then cut it into smaller cubes. So as we go on cutting down the gold, and let us say we are reaching up to the dimension of nanometers, so then you can see, as in the 12 nanometer size, gold particles do not look yellow, what we are familiar with, but it looks red. So why? And you can here also see that the picture which was shown earlier, it is the gold nanoparticles dispersed in solutions which are having different sizes. So each size of nano gold contributes to a different optical absorption or optical reflection. So different thickness of the material reflect and absorb light differently. So that is how the properties are affected when you change the dimension of a material from its bulk to the nanometer dimension. So here you can imagine how much the gold, which was thought of to be a never tarnishing metal, has turned down to a different colors we can never think of, isn't it? So similar drastic change in properties can be observed when you come into the nano dimension. So this is again the 2 to 10 nanometer size of material, which you can see they are called quantum dots, and they find application in lasers. Why? Because by tuning the size you can have different colors to be emitted out, so that you can make it as a laser which can be tuned to give different wavelength as we prefer, or it can also act as a biological sensor, that is based on a sensor based on the material that is getting attached to the sensor. The size of the material will change, and correspondingly it will behave in different colors under different size. So that can also be employed as a sensor. Now nanoscience have always inspired from nature, so the nature is used as template. Let us see how it is. So nature, as you observe around the nature, can see that there is nanoscience is there in every part of nature. Let us see. So here comes a butterfly, and it says, what does it say? These nanostructures don't make me pretty. They also keep me clean and shedding water and dirt. Okay, so the colors in butterfly wings are not due to pigments, but they are due to the different structures of the butterfly. Can you imagine that? Yes, the colors of beetle and butterfly wings comes from scattering of light or interference of light. When the light hits the nanostructure on their scales or on their wings, these structures are very small and it is comparable with that of wavelength of light, and hence they can give a different or interference and or diffraction pattern, and hence it can give a different kind of constructive interference. Okay, so if you look closer into the wings of the butterfly, you can see at the micrometer level it comes in the range of scales, and as you go deeper and deeper, you can see it is having something like setae, like a feather like kind of things, which are called setae, or and these structures are arranged in a regular pattern, so it forms like n slits arranged in a regular pattern, and which can contribute to interference. Okay, so based on the size differences between these setae, you can have different colors. So that is how the beetles and butterfly get their color rather than the pigment as you think of. So the setae are 400 nanometer long and they are responsible for producing constructive interference. Can you imagine that we have been looking at the nanoscience when you look at the butterfly? Yes. So we can get inspired from the nanostructures involved in nature research. Let us go to the next example, the beautiful feathers of peacock. Yeah, we are all very much excited to see a peacock feather, isn't it so? Very intricately varying color shades in its feather, isn't it? We always, when you go and go to or buy a dress, we always get mesmerized with the colors of peacock, isn't it? So how do these colors come from? Okay, our question again is, are they due to any pigments? No. And what is another specialty that is seen? Yes, if you look the feather at different angles, you seems to have a different color variations, and that kind of color variations depending upon the angle at which we look is called iridescence. So what are these iridescence due to? Again, our answer is very simple. The another reason for color is interference of different wavelength of light, like oil on water. You would have experienced um, oil film on rod where it looks like a colored pattern. So the same thing happens on peacock feather also. Hard to believe, isn't it? Yes. So why is it happening? Again, these feathers are made up of nanoparticles which are smaller than 400 nanometer, and they produce iridescence or a rainbow-like color when the light strikes them. And iridescent colors change when you look at the object from different angles. Okay, so all these are contributed by the nanostructures involved in the feathers of the peacock. Another example, Hawaiian bobtail squid. What is the speciality of Hawaiian bobtail squid? Yeah, it is like when a predator comes to attack it or um, to hunt it, what it do is that it has a mirror like thing which and it can also produce a bioluminescent by its own, and it gets reflected from the mirror in the squid, and it gets falls on the eyes of the predator, like we used to play in a childhood, like we used to play with mirror, and when the sunlight falls on the mirror and it is reflected onto a friend, what happens? Her vision, or his or her vision, will be gone for a moment, right? So similarly, the predators, when they come to attack the squid, the squid has got a mirror like thing on its body, so it produces its own light, and that gets reflected sharply from the, or strongly from the tiny mirror platelets, and it falls on the eyes of the predator. So it might um blind the predator for a minute or for a second, and at that instant itself the squid would have escaped from the eyesight of the predator. Okay, so what is this mirror in squid made up of? That is another interesting thing. It consists of stacks of silvery nanoplatelets made up of a protein behind the tissue, and that can reflect the light downward from the squid. So when the predator tried to look at the squid will reflect the light onto the predator. So the predator's eye will be blinded off due to the heavy light falling on it. That's how it escapes from the eyesight of predator. Another interesting example is jellyfish. You would have experienced, or you would have seen in movies, the bioluminescent given by the jellyfishes. Okay, so a jellyfish type invertebrate called siphonophore. It uses red bioluminescent lures created at the nanoscale to attract the prey. Okay, so it produces this lure or bioluminescent color to attract the small fishes or small worms and all, and it can predate on it. Okay, so that is also produced at the nanoscale. Okay, so how do these applications or these templates from nature help us in uh, devising applications? Scientists are making synthetic materials that mimic these biological structures. And what are they used to? They can used in cars or dresses that change color as they move. Can you imagine? You don't have to buy dresses or buy cars of different colors. You just have to have a single color, and based on the circumstance, like maybe on sunny day it would appear at a different color. Maybe if it is rainy, it may appear in a different color. If it is doomy, that is less sunny, then it would appear in a different way. Or if it is dirty, it appears a different way. Okay, so scientists are actually thinking of mimicking these biological structures. So what do they used to? They can change color. So changing color means we are able to sense some change happening in the material. So that is the next application. We can use them as sensors that detect the impurity in drinking water. Yeah, another beautiful one. And another thing is that we can have efficient optical chips for cell phones and authentication marks and credit cards that are exceedingly hard to counterfeit. So all these kinds of applications are thought of by the scientists. Okay, so thanks to the butterfly which has been studied, papilloblumi, to infer the nanostructures. Another thing, so that was about how the color could be changed based on the nanostructure. Another thing we are going to study is the lattice effect. So what is the speciality of lotus leaf or ചേമ്പിൻ്റെ ഇല എന്നൊക്കെ പറയുന്നത്? What is its speciality? If you sprinkle some water on the lotus leaf, or um, what will happen? Yeah, you would have observed the water would roll up, and then it will just roll off the leaf. Okay, so once it roll off, what will happen? It will take away the dirt on the leaf and all. So you always find a lotus leaf very clean, even though it is inhabiting a dirt. The lotus always grows in dirt and mud, but its leaves are very perfectly clean and polished. Why? Because let us see what is the effect. Nature is skilled at fabricating organic structures at the nanoscale. So nature always builds things in the nanoscale. Best and the most known example is self-cleaning surfaces. Those are called self-cleaning surfaces, and which is found in the lotus leaves. So how do they uh, try to be very clean and tidy? How it is done? Yeah, if you check the leaves closer, you can see some structures over it in the nano dimension. You can see something like fibers on the or brushes on the bristles on the leaf surface. So what will happen whenever a drop falls on the um, leaf surface, it will get rolled up. It will not be touching the leaf surface as such, but it will be rolled off or rolled down into spherical droplets due to the presence of these fibrils, which are in the nanometer dimension. So you can think of nanofibers on the um textiles. So what will happen? Yeah, these are called nano whiskers. So what will happen? The water will not be able to come or get or wet the textile or the cloth. So what will happen? Any dirt present on the cloth will be easily taken away by the rolling of water. Okay, can you imagine it? It's a very wonderful idea, isn't it? We are always so much bored of washing our clothes, isn't it? So you can imagine, you just have to dip your cloth in water and just have to take just have to give a uh, nice shaking, which will keep away all the water from the water, not only water, all the dirt from the textile. Another interesting example is water striders. That is, you would have noticed some spiders are exceptionally great in traveling on the surface of water, isn't it? So, are they tricking gravity, or are they tricking the buoyancy effect? So, what is it? How they can walk on water? There is a nano grooves on the legs of the spider. If you check the spider's leg, you can see lots of tubular kind of or grooved kind of structures on its leg, and these grooves are in the range of are in the size of nanometers. So what will happen? These hairs or the grooves will have so much of air. Okay, so you can imagine um, bots, how the bots float on the surface എങ്ങനെയാണ്? Because the bot has like what is it, life boy എന്ന് പറയും, അല്ലെങ്കിൽ isn't it life boy, not life boy, like inflated bots used in river rafting and all. So you would have noticed it is filled with air. So air gives the buoyancy to not to get plunged into the water. So similar kind of thing happens in a spider also. Spider's legs has hairs, micro hairs on its feet, and which are grooved. So in the groove, air will be there, so which will make them to walk over the water. Okay, so similarly, beetles and flies also have nanostructures that helps them to stick to the walls and ceilings and what appear to be very smooth surface. You would have noticed how the flies are able to grip onto the glass surface, vertical glass surfaces, isn't it? And also the spider or the gecko, they can easily stick on to the walls, isn't it? So why we cannot stick on to the walls? We would fall off. but these lizards and the insects are able to stick on to the surface of the walls, vertical walls. Why? How can they defeat the gravity, attraction by the gravity? Because the answer is very simple. This is called gecko, which is supposed to have high, which can stick on to even the steepest mountains. It comes to the reptile family as lizards, and these are seems to have high gripping power to the mountain, steep mountains. Okay, so what are they due to? So in their toes, if you check one of the toe of the gecko, it has 5 lakhs hairs. Can you imagine? 5 lakh hairs are there per toe. And in that hair, in a hair like that, there are hundreds of nano projections, and those are called spatulae in a single hair. So these spatulae will make it to to get attached to any roughness on the surface. So any small roughnesses on the surface will be clinged by the spatulae, which are in the nano dimension. So any roughness in the range of nano dimension could be taken as a clinging material for the gecko. That is how they can get an adhesive force to support it on the steep mountains or walls. And the next example is, we would have noticed the silk by the spiders, isn't it? So even if how many time you have tried to break it off, but it gets sticky, and it is really difficult to break it off, isn't it? So again, these threads are actually nanometer sized biodegradable threads of spider silk, and they are stronger, and they are high, they have a high tensile strength, and they are elastic also to stretch up to 10 times than its initial length. So all these materials, which usually found in nature as super materials, are in the size of nano dimension. Another interesting thing is, you would have noticed the cat whiskers. So what are these whiskers on the cat are used to? Yeah, they are actually the pressure sensors. Okay, they are ultra sensitive pressure sensors, and again their size comes in the nanometer range. These hair like sensors are made up of tiny carbon tubes and silver particles. So we can construct these hair like sensors using carbon nanotubes and silver particles, and they can act as sensitive pressure detectors. Okay, so they can be used as, you would have noticed the artificial intelligence has made many kind of robots, isn't it? So what is the hindering thing in artificial intelligence is that you must be able to sense everything. The robots must be able to sense like a human being does, isn't it? So that is a big challenge in artificial intelligence. So we require sensitive detectors. So one such pressure detector or feeling sensors, or like sensations like touch or smell or something like that, all the sensors have to be sensed by the robots. So these are possible if you have perfect or efficient pressure detectors. So considering cat whiskers as a template, the scientists have thought of um, devising sensitive pressure detectors for the robots, so which can sense the human, even the human touch. Isn't it fantastic how the nanoscience have evolved to the nanotechnology to support the technology? So as nature has template, we can have biomimetic materials, like you could have polymers, which can be inspired from substructure of nacre. Nacre is, you would have noticed the shell of conch shell, conch shell. എന്താ പറയുക, ശംഖ് അല്ലേ, ഭയങ്കര ഹാർഡാണ് അതെല്ലാം. സോ അതിൻ്റെ എല്ലാം സ്ട്രക്ചർ, ഇഫ് യു ചെക്ക് ഇറ്റ് ദ സ്ട്രക്ചർ deeply, it is in the size of nanometer. So you can think of material which are hard, very hard, based on how they are arranged in the neck. And another one is structural elements could be thought of, like wood, ligament, and bone. Okay, what is the specialty of a bone? Yeah, bone is it is stiff. It is actually strong as well as flexible. Can you imagine such a thing? സ്ട്രോങ്ങും ഫ്ലെക്സിബിളും ആയിട്ട് അല്ലേ. നമ്മുടെ സ്റ്റിഫായിട്ടുള്ള ബോൺ ആണെങ്കിൽ നമുക്ക് കൈ മടക്കാനോ നടക്കാനോ ഒക്കെ പറ്റുമോ? ഇല്ല. ഇറ്റ് ഈസ് അറ്റ് ദ സെയിം ടൈം ഇറ്റ് ഈസ് സ്ട്രോങ് ആൻഡ് ആസ് വെൽ as stiff enough. So which makes it a good template for devising structural elements. You can think of your house being moved around as per your wish, and you can think of the you can think of a building to get restructured by its own, so without any damages. Okay, so everything is possible with nanoscience. Another thing is that you can thought of electrical conduction, how the eels conduct electrically. Okay, and another one is photo emission could be think of, like deep sea fish and glowworms are present. So how do they do that? So based on that you can think of getting light out of nanomaterials. And you can think of photonic crystal. Photonic crystal example ആയിട്ട് വന്നതാണ് butterfly wings, birds wings ആണ്. And hydrophobic surfaces or super cleaning, self cleaning surfaces like lotus leaf and human skin, isn't it? Our skin doesn't absorb water. It just നമ്മൾ കുളിക്കുമ്പം അഴുക്കൊക്കെ പോകുന്നത് എങ്ങനെയാണ്? അല്ലെങ്കിൽ വെള്ളം നമ്മുടെ സ്പോഞ്ചി ആയിട്ട് നമ്മൾ വീർത്ത് വരുന്നുണ്ടോ? ഇല്ല. When you wash it off, the water just goes off, isn't it? It doesn't get absorbed. So that is because our skin is a hydrophobic surface. So you can think of such material so it can get cleaned by itself. Another one is adhesives. You can think of super adhesives, taking gecko's feet as a inspiration. And likewise spider silk can be thought of, and human brain can be taken as a final template. Okay, so based on this, a many number of materials like sensors, delivery vehicles, imaging agents, self-cleaning surfaces, self-heal surfaces. Okay, you can think of self-heal. That is, even if something get broken on the surface, it get healed off by its own. Or if you get a wound on your skin, it get heals off. So such kind of surfaces is possible using nanotechnology. So in the coming years you can see the fuel cells to power your car, and intelligent clothing is already available which can detect your medical conditions and monitor your medical conditions and warn about your heart attack or any nervous system or a stroke, incoming stroke. So all these things can be done if you have an intelligent clothing system. And you could have vehicles with very light frames but efficient ones. And you can have biocompatible materials as hip joints and transplants, and you can have solar panels for heat as well as light, and you can have self-healing materials which are highly resistant to corrosion. നിങ്ങൾ കേട്ടിട്ടുണ്ടാവും കായിലില്ല ഉപ്പിലില്ല പൂപ്പിലി വിടാം, isn't it? So the paint also already has a fibers, so which will not allow the water to wet the paint surface. So what will happen? It will not allow any dirt to get mounted on the surface. So that is already available. So you can think of many such kind of things based on nanoscience. So more and more you know about the nanoscience, the more ideas will crop up in your mind. So nanotechnology is basically used for miniaturizing the things and devising novel materials and nano devices, and you can have the concept of building atom by atom and into new materials. Okay, so I end with the flowers, the nanostructures, the flower shaped structures given by silicon carbide. So any kind of structures can be devised which was not thought of in the bulk level. Okay, so thank you.